Welcome to the Phone Free Zone Online Academy of Freedom Unlimited. Today we'll be learning about exponential functions, and our example will be bacteria growth. Okay, so the parent function of an exponential function is f of x equals a b to the x. F of x represents the dependent variable. A represents the starting value. B represents the growth factor. And x represents the independent variable. In our bacteria growth example, f of x, the equation is f of x equals 10 times 2 to the x. Okay, so for our bacteria growth example, we're starting with 10 bacteria because 10 is A, 10 is our starting value, and they double times 2 every hour, which is x. So f of x is the amount of bacteria after x amount of time. Now, some important things to note about this parent function is that, number one, A can never equal 0. This is because if A were to equal 0, then it would be 0 times anything, which would be 0, and there would be no growth. The second rule is that B can never equal 1. Okay? Because 1 to the anything equals 1, and anything times 1 is just itself, so that would mean that it would just be a straight horizontal line. There would be no growth. Again, no growth. Okay, the third rule is that B must be greater than 0. Okay, this is because if B were to be negative, and if it was to, let's say, the 1/2, you wouldn't be able to take the square root of a negative number, or the cube root, or any root of a negative number. Okay, now let's graph the function. So, alright, first we're going to make a table for our x and y values. So if x is 0, y is going to be 10. And if x is 1, which would be 1 hour, y would double, so it would be 20. 2 hours, it'll double and be 40, and so on. So 3 would be 80, 4 would be 160. Okay, now let's graph it out. Okay, so on the y-intercept we're going up by 10s up to 200, and then we're going up by 1s on the x. Okay, here's your graph. Okay, so this graph is going up exponentially, an exponential curve, and it has an asymptote on the x-axis. Okay? Okay, now let's talk about the domain and the range. So, the domain for this function is negative infinity to positive infinity. The range would be 0 is less than y, which is less than infinity. The x and y intercepts. The x-intercept, well, there isn't one. Not any. Okay, so the y-intercept is 10, which you'll notice is the same as in the equation, and that's because the y-intercept is the same as the a value. Except if there isn't an a value, then the y-intercept is going to be 1 because there's an understood 1 before the b value. Okay, so this is our original function, f of x equals x times 2 to the x. That's what it looks like. Now, if we were to reflect that over the x-axis, we would make the 10 negative. So, if you want to reflect an exponential function across the x-axis, you make the a value negative. Okay, so we'll take that away. Now let's imagine we want to reflect it across the y equals x axis, which is this one, and get the inverse variation. That would look like this, and that is log base 2 times x over 10. And we'll get into how you would find the inverse relation a little later. Okay, so if you wanted to translate it up, you would add to the end of the equation. So if we were to add 3 to the end of the equation, it would translate up 3 units like that. It would look like that. Okay, so we'll take that off. And if we were to go translate it down 3 units, we would subtract 3 from the end. Like that, and it would look like that. Okay. And if we add to the exponent, for instance, if we do to the x plus 3 right here, this is what we will get. And as you can see, it crosses at 80, right? Whereas on this one, it crosses at 10. And that is because if you imagine the exponent, if x is equaling 0 and you add 3, then it would just be this to the 3, and that would be 80, right? And so that's your y-intercept. Now, if we were to subtract from the exponent, and we could do x minus 3, it would look like that. And we can go zoom in a little bit. So if you have both of them up, they all three look like that. Now, if we want to reflect it across the y-axis, we would make the exponent negative, just like that. Okay, and that's what it looks like. Now we're going to talk about how to find the inverse relation of this function. Okay, so our first step is to change f of x to y, okay? Y equals 10 times 2 to the x, okay? Step number 2, switch the x and the y. X equals 10 times 2 to the y. Step 3, let's divide both sides by 10. Okay. Alright, so in step 3 we solve for y, and in step 4 we're going to take the logarithm of each side, okay? So we're going to do log 2 of x over 10 equals log base 2 of 2 to the y. Okay, now let's simplify. So we have log base 2 of x over 10 equals y. This simplifies, all that simplifies to just y. So now the final product should look like this. F to the negative 1 of x equals log base 2 of x over 10. Okay, so if you remember the computer example, this is what the inverse relation looks like, okay? And it is just a reflection over the y equals x line, okay? Which is right here. And that's our original function, and this is the inverse. Okay, so for the domain and the range of our inverse variation, you'll find that they're just swapped from our original function. So the domain would be x, which is less than 0, is less than infinity, much like it was in the original, where it was the range was y is less than 0 is less than infinity. Alright, and then the range, we can think about what's the domain for our original, and that would be negative infinity to positive infinity. Well, what's the range for this? Same thing. Negative infinity to positive infinity. So right now we have starting with 10 bacteria, and then every hour it doubles. Okay, so let's say that our question is, after a day, how much bacteria do we have? Okay, so it would be f of x equals 10 times 2 to the 24, because 24 hours. Okay? Now, okay, so the answer is 167,772,160 bacteria after a day. Alright, so our next question is, let's say we have 10,000 bacteria and we're wondering how many hours did it take to get there. Okay, so we would solve that by using the inverse formula. Now that would look like this. Log base 2 10,000 over 10. Okay, so let's use our calculator to figure that out. Alright, so the answer is f negative 1 of x equals 9.9657. So it's approximately 10. So let's just plug this back into the original equation and see if we get 10,000 out of it. So we're going to do 10 times 2 to the 9.9657, and we get 9,999.4. So yes, this is correct. Thank you everyone for attending a day at the Foam Free Zone Online Academy of Freedom Unlimited. Hope you had fun. And now I'd like to thank my director and my live audience. Thank you.